Okay. Uh, Before we went for the break, we saw user-defined functions. Now let us understand the concept of local and global variables. This concept of local and global variables is, again, I am saying, is not common or only in R. Is again across tools. Across tools, there is a concept called local variable and a global variable. And the concept is simple. Variables which are declared outside, they have a global scope. Variables which are declared inside a function, they have a local scope. What it means is, if I declare a variable inside a function, I'll not be able to access that variable outside the function. But yeah, if I declare a variable in the global environment outside the function, it will be available across everywhere. Okay. So here, let us first, I'll try to explain on the slide. Here I am declaring a variable AA10. I am declaring a variable BB10. 20, sorry. I am declaring a variable BB assigning the value 20. Now I am calling a function. Now I am declaring a function. So here this part is creating the function. When I run this, it is not going to execute, it is going to compile, which means after running the function local from braces open to braces close the first time, it is going to compile. Function will execute only when I call the function. Okay. So here I have written some statement print AA, print BB, and then I am saying AA equal to AA plus 10, BB is equal to BB plus 10, and then again I am doing print of AA and BB. Now here I am calling the function. Now when I call a function, what will happen? When you call a function, the logic inside the function gets executed. What all statements are there inside the function? They get executed. So the first statement, when I call, because these two variables are already declared, so when the execution of the function will happen, it will going to print AA. So value of AA is going to get printed. So I'll get a value of AA. What is AA assigned? 10. When I call print BB, BB is going to get printed. What is the value assigned to BB? 20. Now because these two variables are declared outside in the global environment, you can refer them and access them. And that's why these prints are working. Now I declare now I'm calling this AA equal to AA plus 10. Whenever there is a assignment statement, first thing is right hand side will get compiled, evaluated. So right hand side is AA plus 10. What is the value of AA? 10. 10 plus 10. Now on the left hand side there is AA. A new variable AA is going to get created, to which the value 20 will be assigned. So AA will get the value 20. So a new variable has got created here. Now this variable, where is it created? Inside the function. So the scope of this AA will be inside the function. Now the scope of this, see when you write something, something this side is equal to something here. This a variable gets created. Okay. So here a new variable AA will be created, to which the value of 20 will get assigned. Now here BB plus 10, it will get evaluated. BB is 20 plus 10, 30. The value 13 will be assigned to BB. Ideally a new variable BB should be created. But what will happen? A new BB will not be created in this case, because note the difference. Here I have got angular bracket hyphen, and here I have got angular bracket hyphen. Now this angular bracket hyphen says that refer the global variable. This value has to be assigned to a variable which is already there in the global environment instead of creating a new variable in the local environment. As such, this BB plus 10 will get evaluated, and the value, whatever is the value, will go and replace the value of this BB. Here I used only single angular bracket, that's why a new variable got created in the local environment. Now when I print AA, what will the value of AA? Because of the preceding step, AA plus 10, 20. So it will print 20. So this AA 20 will get printed. Now when I say print BB, it should be 30 because 20 plus 10, this was BB 20. This 20 plus 10, 30. This 30 was assigned to BB and we said change the value of the global. So here there is no local BB. So it will access the global BB and print 30. So far the function execution local is there, all okay. But now let me access AA outside the function. AA is again 10. Here AA printed 20. But AA is now printing 10 because this AA to which the value 20 got assigned was a new AA created in the local environment. So that's the reason AA. Now here when you are referring AA, it is referring to AA which is in the global environment. And now when I say print BB, the value will still be 30 because the value got here computed 30 and I used double angular bracket. The double angular bracket said that go ahead and change the BB value for the BB which was in the global environment. So this BB which is in the global environment, its value got changed from 20 to 30 and now when I print it, I get 30. Local and global.
So why are we creating one in the local and why one in the global? What's the purpose?
So a good question, why are we creating one variable in a local environment and one variable in a global environment? The objective is to explain local and global concept. That is one. Second thing is when there is a local and global concept, to avoid confusion, you should not name variables same in the global and local environment. This will make your code simple. Okay. So here, if I really wanted to create this as a local variable, instead of saying AA, I should have actually said it CC, some other name.
What's the difference in local and global environment? What is the use?
Just to explain this concept further, why local and global variables are required. See, many of the codes would quite often use loopings. You want to probably loop around. And it's a common strategy between coders. Whenever a loop is to be written for I is equal to 1 to I equal to 10. Now this loop code is in a function. Now this I is declared in a function. Another function might also have some looping logic, and again it would be I equal to some number counter to some counter. Now if this I which is written in a local function which is created in a local, if that I value is available outside also, what will happen? Another function will get impacted just because the value of I in one function got reassigned to 10 and now this function was to start from 12 but its I is starting at 10 because it was assigned because the local variables are also available outside the function. To avoid this kind of a problem, the variables which are declared inside a function, their access is restricted within the function. Variables which are outside the function are available everywhere. Okay. So let's try and run this syntax.
You're changing the whole global variable. Like
If now why am I changing? I'm just trying to show that if required, you can change a global variable in a function also. That functionality is available. That functionality R is giving you the functionality by which a global variable, if you want to make a change in a function, you can make. Okay. Now let us try this. And as I run this syntax, I'll make some changes also to explain. Let me just run ls command first. I don't have any variable cc. Okay. So I'm first creating variable a, assigned the value 10. I'm now created a variable bb. Now in this function, let me create cc also. cc 100. This is a local variable and referencing outside will give error. Okay, because there is no cc outside in the global environment. So now I'm creating this function. So let me compile this. So the entire function is compiled. Let me call this. So I should have put a print also. So let me just print syntax also. Print cc. And let me compile this function again. Control R. And let me call this. So here, this is AA, this is BB, this is AA, this is BB, and this is CC. Now I'm accessing AA, which is now going to refer and print global AA, because this print AA is outside, so it is going to refer this global AA, and it is going to go ahead and print, and the value of this AA will not change despite we having changed here AA equal to AA plus 10. The point is to show this AA is a different AA than this AA. So I'll just print it 10. This BB is going to print BB plus 10, 30. So this BB is going to print 30. No, this BB, let me, because I executed this local function twice. Let me just 1 minute. A control R. I've reset the values. I am compiling this function. I need not compile it, just I'm compiling this function. Now calling this. This is 10, 20, 20, 30. I called the local function only once. Now print A will show me 10 only, and print BB is going to show me 30. If I now type here print CC, what is going to happen? Object not found. Why? Because this CC is created here. I did not create CC because I showed you ls. There was no CC object in my memory. So this CC is not there. So object CC not found. So any variable created inside a function will not be accessible outside. Now here, as a best practice, what we should have done, we should have not named it as AA. Ideally, if you are writing the entire logic and you know global variable you have declared AA, there's no dearth of names. I just say AA1. This would have avoided the entire confusion. Here I cannot make it BB1. Why? Because here the objective is to change the global variable. So here I cannot change and make it BB1. But here I could have avoided the unnecessary confusion but the entire intent was to explain the concept of local and global variables. Okay, so just try out this entire syntax. I'll highlight it. Just try it out. So you would have noted the usage of this double angular bracket and hyphen. Let's move forward. Now let us understand some basic programming structures. Programming structures means looping conditions, for loop, while loop, do while, these are all called programming structures. And then if else conditions. Quite often we have criteria like if a particular condition is met, then something should get executed, else if a particular condition is met, then do something else, and so forth. So these are called programming structures. Okay. Simple logic approach is quite similar to all other tools. When you run a for loop, you typically start for loop from a starting counter position. Some counter position, you will say counter equal to 0, counter equal to 1. Then you have to run it number of times. So how many number of times you want to run? Say you want to run it 100 times. So you'll have to specify counter equal to 1 to 100. Now when you say counter is equal to 1 to 100, by default it will increase by 1 each time the counter moves forward. Likewise, I can specify instead of for, I can say while. Typically, while is used when you know the terminating criteria, but you don't know when that terminating criteria will reach. For loop is used when you know the number of times you want to run a counter. You want to run the same set of batch of code, how many times you want to execute it. You typically use for loop. And while loop is executed while the statements are getting executed, some value keeps changing, and when that value reaches a threshold, for example, I am running a logic which is trying to minimize the error. So there is a target and I've got some logic by which I am trying to reach that target value. I know when I reach the target position, say I reach the target up to a closeness of 0.01, which means my predicted value of my target, my calculated value is close to the actual target and the difference is only less than 0.01. Now to reach that position, I will not know how many times I have to iterate. In that case, you use a while loop. For loop is used when you know how many times you want to execute a particular set of statements. While loop is used typically when you, by continuously iterating, your value is going to keep changing, and when that value reaches a particular matching criteria, you want to loop out. While loop is used in that case. Fundamentally clear? So this is a for loop, this is a while. Both of them needs to have conditions. Both of them needs to have a condition. So here I'm just given a simple application for I in 1 to number of rows. So basically whatever is the value of n row LRDF, in this case it will be 20,000. So this loop, which part of syntax is? This part of the syntax is brace open, brace close. This part of the syntax is going to run 20,000 times, and each time it runs, it will do processing for this particular column for that ith position, which is decided based upon the counter value. Yeah, and then it keeps changing it. So let's try and run this syntax. So here, okay, the code is, sorry, the code is not in this case. 1 minute. Here is this entire code. Before I run this statement, let me just check what is the class of occupation. Class is factor. I'll not do this logic directly because the class is factor. If I run the logic directly, I'll not get the desired result. Okay, so what I'll do is I'll first cast it. As dot character, and then I'll have to say lr underscore df dollar occupation. Okay, I've casted it. This start time, I'll just run it. You need not type and run it, but what I'm trying to do is I'm going to take what is the current time and capture it, and then I'm running this entire loop. Control R. The loop is executed. End time, I'm now noting the end time. I've spent some time in it. Actually, I should run the syntax like this, so that the delay which I had between running the two syntaxes, that delay should not be there. Otherwise, the objective is not served. So let me run this piece of code together. And this gives me what is the total elapsed time. User time, system time, elapsed time, 0.22. To run this entire code, it took 0.22 milliseconds or something. Yeah. So that is the time it has taken. After having executed, let us see whether these double quotes which are missing, have they got converted to NAs? So I will run table NAs. So wherever there was a missing, it is now coming as NA. Okay. Let us quickly go into another logic, if else also. Let me explain if else syntax also. So here we did for loop. Now if else is basically a way of writing a code where you say if a particular condition is met, then do some step. If you have an alternate to execute, if the condition is not met, then you also have a else part. So there are multiple ways to do. One is called if. Basically in this, if a condition is met, do something. Else there is nothing, so you don't say else. But if there is something called else also, which means if a condition is not met, then what do I do? Then there is something else to be done. In that case, you have to go with a if else syntax. This if else can also be written like this. If condition true, then what should happen? Else what should happen? If you have worked on Excel, you will know Excel implements this if else, the third one. Okay. So here again what I'm doing is I'm doing a start time and process time. In the previous step, what did I do? I converted for all rows. I found out any row which has a missing value, then I converted it to NA. Now here what I'm going to do is using if else, this third syntax, if there is any value which is NA, then I'm going to replace it by miss, else I'm keeping it the same value. Okay, so I'll now run this part of the code, and again what we are going to see is what is the total amount of time it takes. This is my if else syntax. Start time till end time, I'll do all these steps together and get the process time. Here it took 0.22. Here it took 0.02. Let us just see 0.22 divided by 0.02. Basically, the second syntax executed 11 times faster, or I can say the first syntax executed 11 times slower. Yeah, this is something. What I'm trying to explain here is, typically when you write a simple syntax like this, let me highlight that part of code. This part of the code, have I put any rectangular brackets here? I did not put any rectangular brackets. By default, what it means, it has to run for all rows for this column, right? In the previous code, what I was doing is, I was putting a condition for. So the for loop has to keep checking whether the value of I is within 1 and 20,000. That adds overhead, because if a value of I becomes 2000, 20,001, it has to stop. So each time it runs, it has to check value of I. That adds to overhead. And then again it is doing the same thing. If it is check, is the value is same, and now what only thing is, it is processing only one row at a time. Only that row is getting processed for which the value of I is provided, and it is causing the entire delay in code. And this code executed 11 times slower than the other code. So when you are writing such simple logic, don't try to process row by row, because by default when you give any column equal to something, all rows will get processed in R in one go. Yeah, use for loops only where it is needed. Okay. So these are the syntaxes that you have to now try. I'll just highlight them. First, check the class. After having checked the class, so here this is just a quick example where I'm showing how functions that we create can also be used as part of sapply and all those things. So we'll not execute it, but here what I'm doing is, I'm writing a function which takes one argument, and I'm calling it if. Okay, and the logic is same if else logic that is written, and then I'm using the return. So it compares the argument value. If it is missing, it makes it back to double quotes. Yeah, and it returns that value. And here if you see, I call this using sapply. As I said, sapply will run for all rows. Apply is the only function where you can specify 2 or 1. If you specify 2, it will be by column, 1 is it is by row. But here I'm using sapply. What does sapply return? Sapply returns a vector. Now if when I run this, for all values of occupation, it is going to keep calling AI function. Yeah, and it will return a vector. What is each column of a data frame? A vector. So a vector, and what will be the size of this vector? The size of this vector will be equal to number of rows of LRDF occupation, that is 20,000. And this is, I'm now taking this vector of 20,000 and putting the values here in occupation column. So occupation column values will get changed. So this is what example of sapply and using a user defined function. Yeah. And once we do this, I'm back to empty. One missing values for the occupation field. Let us just summarize the operators. So the operators available are plus, minus, star, divide, slash, exponential, so double caret or caret or double star, same as in Excel. In Excel also, this is how we use power. I want to do 3 raised to 2. I can say 3 caret 2 or 3 star 2. Modulus, basically, what is modulus? Modulus returns the remainder. So if I do, say I run this modulus command, say I do 44 percentage 12. 44 is not completely divisible by 12. 12 is a 36, 12 was a 48. So the closest value I can reach is 36. So it will show 8. When I run this command, this is called modulus. When we have remainder, it is called modulus. If I want the quotient element, percentage slash percentage. So the same syntax, if I would have written like this, percentage slash percentage, which I'll just put spaces, it would give 3. Okay. So this one is less than, greater than, less than equal to, greater than equal to. Double equal to is for equal to comparison, and exclamation equal to is not equal to. Ampersand or double ampersand is and, pipe or double pipe is or, negation, exclamation is for negation, percentage in, percentage is to check values of one in another. Okay. This is wrong. Checks values of x in y, checks values of y in x. Okay. So these are arithmetic and Boolean operators that we keep using, comparator operators. So with this, most of the elements which are typically required in any programming is done. Let us quickly see charts and graphs. The way we are going to do charts and graphs is I am going to run these codes, some of these codes, and quickly explain. Okay. So various types of charts and graphs: histogram, Pareto, box plot, pie, line graph, scatter, overlay graph. So example, histogram. What is histogram? Basically, we just see the distribution where each value is shown as a bar, right? So this is like a histogram. This histogram, right? So here I call a function hist. Histogram is to be created for, typically created for continuous variable types. So I am passing age as a variable for which I want the histogram. I am saying main. I have to give a label to this graph. So I'm saying age distribution. I have to give a axis labels. X lab is X axis label. Y lab is Y axis label. So I'm saying Y axis label. Color orange. So this creates a histogram. Pareto. What is Pareto? 20-80 rule. 20-80 principle is called Pareto. What does 20-80 principle say?
80% of the work is done by 20% of the employees.
So that is Pareto. So 80% of the work can be completed in 20% of time. Effort. But to complete the final 20%, you end up taking 80% of time or effort. So quite often if you are given some work The quick wins we all solve very fast. Quick wins, easy things we completed. So if I give you a checklist of work, first what we do is typically identify which can be done quickly. So that is like we complete 20% in 20% of time, 80% of things will be done. But the last mile takes a good amount of effort. Similarly, the other application of Pareto is when you get complaints from customers. If you analyze customer complaints, most of the times you will see many of the customers complain the same thing. If you resolve that complaint which many of the customers are saying, you will see that one complaint resolution or solving one type of a problem, it will ease out many customers' complaint. So that is 2080 again. So there will be some 20% of types of complaint which will cover problems of 80% of the customers. But the remaining 20% of the customers will give so widespread different types of complaints that you'll have to solve one by one. Okay, so that is called 2080 rule. Now here I'm just using a package called QCC for creating this Pareto. Now Pareto is basically, I don't have an appropriate column to create this Pareto. Age bucket is not the right type of a column on which you create a Pareto. The Pareto should be created on something. If I would have got a table which has different types of complaint and how many times it is occurring. In that case, you first take the complaint which is the most occurring. That complaint you will have to put first. Second will be the second most occurring. Okay. Third complaint will be the third most occurring. So basically you arrange them in a descending order of their frequency. So here, because I don't have an appropriate column in my data, I've taken just a age bucket. And then automatically what it has done, if you see, age buckets are now not coming in the order. They are coming in order of the frequency. So I require a frequency table, and then I call a function, Pareto.chart function, to create the Pareto chart. Once you write this part of code, again main, xlab, ylab remains the same. Call is basically to generate different number of colors. For all of them, I'm using a function topo.colors, which will give me 7 or 8 distinct colors depending upon, because there are 7 categories, it has given me 7 distinct colors. But the concept of this is, Pareto concept is clear. 2080, the concept, if the concept is clear, it's syntax. Yeah. Box plot. Box and whisker plots. These are typically called box and whisker plot. Why is it called whisker? We'll see. Yeah. So box plot, this is a simple box plot where I'm using only one variable age. So what a box plot gives, it gives you median. This line explains the median. This gives you third quartile. This gives you first quartile. Now there are certain values which are above third quartile. This gives you, ideally it will not give you max. Ideally it will give you a certain level after which there are outliers. So it will ignore the outliers and then arrive at a cutoff itself. Yeah. So, and similarly at the bottom side. So here I have done a box plot of age. But if I want to see the age distribution by, say, gender. So I've got 3 columns on gender and then this thing. Okay. I want to make it colorful. I add this color element also. Okay, I have now given 3 different colors myself using a vector. Okay, I could use topo also. What we did here, call equal to topo.colors, count of distinct categories, I could have used there also. Let me make this box plot for balance column, because the point, the whisker elements and the outlier element is not coming clear using the age. So let me show how a box plot can give you a visual indicator whether a particular column has got outliers or not. See, if we are not able to find out outliers using a percentile function, then the best way to have a graphical way of finding out outliers are there or not is a box plot. Okay. So let us create the box plot of balance as with respect to gender. This is the code that I'm running, and here you see this box plot. As I said, this line which is coming at top, it will identify up to what value are not outliers. Typically it will take 95, 97, 99, some cutoff, or automatically determine. These dots indicates these values are outliers. Is there any dots on the downside? No, because 0 was actually not an outlier kind of a value. So the graph automatically finds which side you have outliers. So using a percentile, if you are not able to find out, using the box and whisker plots is one of the best way to find outliers in any given column. Okay. So coming back to the presentation slides, pie chart. This is an example of pie chart. Typically, I did not get an easy way out to create a nice pie chart, so there is a slightly complicated code. When you create a pie, what are the things that you would like to see? Label for each pie and percentages. Basically, that pie represent what percentages. And at times you may also want to see absolute number of counts there. So here, what I'm doing, a pie is basically what a frequency distribution. Which category has got how many observations, and that frequencies then gets converted to proportions. So first step is table function to get the frequency distribution. Once I get it, then I'm converting these frequencies. The pie CNT contains the frequencies. I'm converting it into percentages, and then I'm creating this entire label. If you see, this is the label legend for a given category for pie. This pie represents 26 to 30. These many observations are there, and this is the proportion, right? So here this entire logic which is written from till here, this entire logic using a paste function. Paste function is a function which is concatenating, basically concatenate values. So using this paste function, I'm getting percentages, I'm getting the labels, and I'm also getting the counts. So all these things I'm getting and then putting them together, and then using a pie function where I'm passing this table, the name for this pie chart, and then finally what label it should show. So it is automatically now using all these things. Labels is basically legends. In Excel we call legends. So these are the legends. And this box is just to put a rectangular box outside. Yeah. Bar plot, just similar to pi. First I need a frequency, so I'm taking a frequencies, and then I'm taking a bar plot function. So bar plot functions is going to plot these bars for given categories. To get these values, these text counts, additionally I have to use the text function. Okay. Grid is basically to create these dotted grid lines which you can see, and box is to create this external box. Okay. Sorry, we already seen. Scatter plot. When do you use scatter plot? Scatter plot are to be used between continuous variables. You don't use a scatter plot with categorical and continuous variable. You don't use a scatter plot with categorical and categorical variable. If there is a categorical and categorical variable, what will you use? Cross tab. Cross tab is to be used. When there is a categorical variable and a count, you use a bar plot or a histogram because you are showing the frequency. But when there are two continuous variables, you use a scatter plot. Okay, so this some syntaxes, the file is already shared. So this file I'm just importing because the current data does not have some sensible data to create a scatter plot. So I'm importing it, and then I'm trying to show relation between income of a family and expense of a family. Okay, and this is a kind of scatter. And if I want to build an equation y equal to a plus bx, okay, then I can use a lm function also. This actually should not be income here, actually it should be expense here and income here. The expense and income positions here and here. Expense should come before tilde, this is called tilde, and income should come after tilde. Okay, so this for a scatter plot. To make a scatter plot, you directly use a plot function where you pass the variables, the two continuous variables between which you want a scatter plot. Main, xlab, ylab remain the same. PCH is equal to 1. What is this? PCH is pointing character, point character. So here these are rounds because you have given 1. If you would say 2, 3, 4, 5 or something 6, 7, so it will, in Excel you would have noted the marker. You can have round, you can have rectangular, you can have triangle, you can have star. So depending upon the value 2, 3, 4, 5, 6, what value you give, this may, the shapes will change. The shapes can become like this, shapes can become like this. Whatever is the number, depending upon the number, the shapes will change. The shapes can be rectangular, but if you say 2 and assume 2 represents triangle, then all these dots will be represented as triangle. That's the point I'm trying to make. Yeah. If you just put the entire data frame, which you should not. If we simply use the plot with entire data frame, then R will compute scatter plot for all possible combinations. So be careful while working with big data set, it will hang the machine. Don't just write plot and the entire data frame, because what it will try to do, it will try to do all combinations possible. Certain combination which is like gender and age, which don't make sense. Because age is categorical, but it's try and make it. Okay. So scatter plot, those should be avoided. Line plot, you have got basically this, instead of having bars, I want a line. I use a line plot. Okay. These are various options. Like when I'm making this line plot, these are various kind of options. P is for points, L for lines, B for both. Let me try and run this line plot also so that you can visually see what these types of plot options mean. Okay, let's see line plot. I'm doing age frequency table first, and then I'm using this plot function. Okay. Okay. There are various options. If I say type equal to L, these options are explained here. The type. P is for points, L is for lines. Let me change this L to P and let us run this function. If you see now it is only points. Yeah. This PCH is for plotting character. Yeah. So let me change this PCH to 1. Now it will become rounds because that time we saw that 1 was round. If I make this PCH equal to 2 triangles, this P, if I make it L, now if it is L line, the moment I make it line, these triangles PCH plotting character will not have much importance. Yeah. But if I say line as well as point B, there are other options. I want C for the lines part alone of B, O for both overplotted, H for histogram. So let's change it to H. So if I want this as H, histogram kind of a output. Yeah. So these are the various option, and like line width. I have not used that option. So let me make it line L, and let us just give some value LWD equal to say 5. It becomes thicker line. If I make it LWD equal to 1, it become a thin line. So these are various options. The reason why I'm not asking you to run all the syntaxes now is these, depending upon when you require which type of graph, you can go and see and make the graph. Overlaying charts. Here I'm basically overlaying two charts. So first is what I'm doing is line plot data. I'm getting a frequency. Then this is a plot function. Type equal to L. Labels PCH and color equal to blue. So you see this is the first graph that I'm getting. On top of that, I'm now putting another information which is of say another variable, and then I'm saying I'm calling this lines function. This will overlay on the same graph. The lines function will work on the same chart on which we have plotted in the previous step, and that's how I get this lines. Now let me explain a package which is ggplot. So what we have covered here is different types of plots. I quickly summarize. We have covered histogram, Pareto, box plot, colorful box plot, pie charts, bar plot, scatter plot, line plot. These are the most of the times, these are the graphs that we use. Okay. Now let us understand ggplot. ggplot stands for, GG stands for grammar of graphics. GG stands for grammar of graphics. What this package says is that when you are making plots, what actually you are doing is you have a canvas. On that canvas you are putting some information, and then on that you are overlaying more information. Typically plots are made that way. So you have some information, on that you can add some additional information, and then you can add additional information. So you can keep on adding. Okay, so that's what ggplot says. The second element is basically facet plotting. At times I may want, say I want age distribution, but I want age distribution by gender. So basically this is called faceting. I want to see the distribution, but I want to see the distribution separately for male and female. Okay, I want to know how is the bank balance of my customers. I would like to know that, but I would also like to know the bank balance by type of account. How is the bank balance of current account customers and how is the bank balance of distribution of savings account customer. This is called faceting. When you want to see the same information but for different categories. Yeah. So ggplots help you do that faceting also. Here, to make use of ggplot, there is a package called ggplot2. Okay. So we are going to make use of that package. First, I create an empty object, ggplot. Now the moment I make this empty object, and if I run this syntax ggplot again, a blank canvas will come in front of my screen. On that I can then say I can add information. So here what I do is ggplot is equal to ggplot plus additional information. So here I'm saying geometric points be plotted from a data which is LRDF. Now aesthetics element, basically axis element, x-axis be age bucket, y be balance, and then I again say ggplot, and this is going to plot. Let me run this code to show the output. Yeah. To avoid the confusion, here I have named it as XYZ plot because we are using ggplot and as a function also and a package also. To avoid the confusion in the code here, we have named it as XYZ. So library ggplot2. First the package is getting. Now I say XYZ plot is equal to ggplot. A blank object of ggplot is created, but it is still not showing in the canvas here. So what I'll do is I'll just say XYZ plot. Can you see a blank canvas? Okay. Now I'm saying XYZ plot is equal to XYZ geometric points. There are many other things. If you type this, we can keep finding out geom underscore. There are many options. Okay. Error, count, crossbar, curve, box, and so forth. Depending upon requirement, we'll have to explore them. For now, I'm going with geometric points. The data will come from which data frame? LRDF. Aesthetic elements, X is, I'm saying, age bucket. So age bucket column of LRDF I want to take, and on the y-axis I want to plot the balance for various age categories. So this one. No change is going to happen here. Why? Because still the object is changed. I have not said show me the change. Now I'll say XYZ plot. The graph is changed. Yeah. Now on top of this, so here what this graph shows you, this is age bucket and these dots represent each row. Wherever age balance is something, say balance is 40,000. So that 40,000 is represented here, this one. So if there are 10 customers having 40,000, 10 dots will come, and because they are overlapping on each other, will not be able to see 10 dots. It's just showing that, right? Now I want to additionally add what is the mean balance, what is the average balance of each of these age buckets. Okay, so here I need to now compute average. So I'm using a plier package to compute. Average has to be computed for age buckets now. So first I'll compute that value. Okay, so I've run some code where I'm using ddply function. Dimension is age bucket, and what I'm computing? Mean. Okay, and what I'm computing? Standard deviation. These are two elements I'm computing. Let us see this computation output. This data frame DS contains this structure: 25, less than 25, greater than 50, 26 to 30. All these categories are there. X-axis categories are available with me. Corresponding mean and standard deviation values are also available. I want to plot. I want to plot the mean here. So again what I'm going to say, XYZ is equal to XYZ plot plus, because I'm now adding additional information to it. Geom point. Now data will come from where? Data will come from DS. So data is here. Axis information age bucket. Y is equal to mean. Color is red. Size equal to 5. So I'll add this to XYZ. Will it show? No. It's not going to reflect unless I say XYZ plot again. Yeah. I want to also show standard deviation, because mean is just 1 point indicator. Mean is always a point estimate. But values, all values are not mean. Values are dispersed. So there is always a standard deviation. So I want to show one standard deviation of this. In my previous step, I had already computed standard deviation also. So DS already has standard deviation. This is what we saw here, right? DS has got the standard deviation information also. Now I'm going to plot that also. So what I'm going to do is XYZ is equal to XYZ plot as a, I want to show standard deviation as a bar. So I'm saying error bar. Data is coming from where? DS. X-axis is age bucket. Now standard deviation has got what? Mean plus standard deviation, mean minus standard deviation. I want to do one standard deviation. So I have to say Y is what? Mean. Y min is what? Mean minus standard deviation. Y max is what? Mean plus standard, one standard deviation. So I'm putting these. Now these are all aesthetics of it. For standard deviation, these information are required. So I'm providing all of these information to it. Color equal to blue. Width is equal to 0.8. So I add all of these. Ignoring Y aesthetics. Okay, ignore it. It is not yet reflected. It will reflect only when I run this XYZ again. So I run this. Yeah. Now can you see that we are adding information one by one to this graph? And this is called grammar of graphics. ggplot is saying that you add information layer by layer when you make a graph. And this is what is possible using ggplot. So ggplot is one of the package, very used package in R for graphics, charts and plots. There are other packages also called lattice and something. So you can use those. LATTICE. Okay. There is a couple of more packages which provide these kind of functionalities. Now here again you can see this. It is very clear when you are making plots one above other. There was a black color which is the circle, red color came on top of it. Can you see this blue color coming on top of red color also? Because it is adding another layer on top of that. If I would run this command again, mean one, and then run that again, so red will overlap the blue line. Yeah, definitely. Most of the times we are not going to run these manually. Why? Because to make some of these graphs, charts and other things, you will use slightly graphical versions, which is many a times you may use R pivot table. I'll just show that also. Okay. So this is the entire thing, and there is one more element to it, which is called facet plotting. So here I'm just the graph is again being created. Here ggplot, a blank object is created. Now here I am saying I want to get the balance and by distribution by balance. So I'm making this. Now what I'm saying is facet this information with respect to a column, say target. The graph that was created, I'm saying facet it with respect to target, and the entire graph will get changed. Let us try and run these three syntaxes. Okay, so let us see the facet plot. Here I'm just creating a object, blank object of ggplot by name facet plot. Now in this facet plot I'm doing facet plot equal to facet plot plus geom point. Like the first step, I'm just putting the balance as a distribution. So here we just do it, and then I'll run this facet plot command. I got a simple graph, age versus balance. Okay, now if I want to do this faceting based on a column saying target, in our data target is a column where there are two categories. One is value is 0 and other is 1. Zeros are actually basically the customers who are of a responder category, and zeros are basically of the non-responder category, and 1 is basically customers of a responder category. I just want to see how the balance distribution is based upon the two categories. Ideally what you would do is you would have taken the data separately for 0 and then plotted one graph, and then you would have taken the values of ones and then plotted a graph separately. But ggplot gives you a very simple function which is called faceting. Okay, so when I say facet this graph, facet it by the variable. So I'm saying I wanted to do target with respect to target, anything else. So I run this, and now I say again this. You see the old graph has been converted into two graphs. One is for 0 and second is for 1. Yeah, so this is called faceting. Make sense? Now there are many graphs that we are creating. Sometimes it may so happen that we would not like to create all these graphs. There's a package called, some of these graphs can be done easily using pivot table. So I have a package rpivot table. The package is already there on my machine. If it is not, you have to run this install.packages command. To this package, I am directly providing the entire LRDF data frame. The moment I do it, I get this kind of a view. Let me blow it up. What I can simply do is I want certain things. I want, say, gender. Okay. I don't like this graph. I want it in a bar, table bar chart. Not table bar chart. Okay, bar chart. We learnt bar chart. On age we did it. I can get a bar chart.
Then writing all those syntaxes, it's better to just.
ये homework देना चाहिए था.
Yeah, you could do that.
ये homework देना.
Or let me now remove this age. Let me get occupation.
So that's what she said.
Bar chart with occupation. Yeah, I don't want count, I want a count as a fraction of total. Okay, so now these have become fractions, but bar chart showing fractions don't make sense. Let us see whether it has got something called pi, but it does not have pi. Let's see area. What will it do with area? No, it don't make. Uh, so if pi is not there, let's use heat map. Okay, so it's showing me the distribution, proportions. Yeah, I want a cross tab between two things. So let me take occupation versus gender. So here it is giving me proportions. I don't want proportions, but I want sum. But I want sum of what? I want sum of what? I want sum of balance. I've dropped it balance here. No. Is it creating so many categories of it? It should not. I dropped it here. Okay, I'll ignore this. Too many list. Okay, it says too many list. So let me remove it again. This sum should actually, sorry, I should have taken that balance here. I was just doing drop as drag and drop like in Excel. So I should take this balance. So it is doing sum of balance. Yeah. Uh, I don't want to see all these categories. I don't like this other category coming. I go here and I remove this. Okay. I don't like this miscellaneous category. I go here. I select this. Yeah. So all these things you can then play around with our pivot table. Many of the charts, if not all kind of chart, we saw that pie chart is not showing. But the point is, for example, I'll just remove all of them. For example, I want a scatter. Is a scatter chart is there. Now to scatter, you require continuous column. So I'll have number of credit transactions on one side, and I'll have say score on other side, or I'll take holding period. It has got less range. So this is a scatter, because for all of these categories there is a value. So scatter plot, there is not much relation. For all of these there are values, so it is showing all of them. But if there is some sensible variables between which you can have a scatter, so it will help. Yeah. So these are the various kind of charts, graphs, heat map. What will happen? Oh, good. A big heat map has happened. Yeah, and it's doing sum with balance. Rather than I'll say not sum, I'll say count. So a nice heat map. So for some of these things we'll have to now then keep, see, these indicates, colors are indicator of concentration, how many records are there. The more the red, more darker the color, more observations are sitting in those cells. So this is how you can do uh, charting, graphing, some amount of visualization using R. There are many other packages, as I said, Lattice. One of the other packages is R Shiny. R Shiny requires too much of coding. Okay, which will, but once you make it, R Shiny is often used for dashboarding purpose. Yeah, so more things to explore. With this, we conclude our R sessions. Thank you.